Welcome students. Today we will be covering one of the topic of calculus, that is partial derivatives. As you have already covered the differentiation in your intermediate classes, so it's the partial derivative is just the advanced version of this differentiation. Okay, here the different earlier in the differentiation, if you recall, let us say if a function is given as x square plus 2x, then our differentiation was like 2x plus 2. Okay, so in the previous cases, in the intermediate examination, the differentiation, simple differentiation which you have covered, is consisting of only single variable. Can you say this is a function of x only? Okay, but now partial derivative is like it consists of two independent variable. Okay, so partial derivative consists of more two or more than two independent variables. Okay, more than two independent variables. Let us say if a function z is dependent on x and y, then we can say this is a combination of two independent variable. There might be some other cases where we have dependency over three variables x, y and z. There might be some cases where we have independencies about four variable. Okay, so earlier in the earlier cases we were entirely dependent on single variable, whereas in the case of partial derivative we will be focusing on more than two or two variables. Okay, so this is the basic difference between differentiation and partial differentiation. Okay, so let me write an expression. Let z is a function of x and y. So how do we differentiate partial differentiation? Okay, let's say there are two variables. Z is dependent on x and y, so there are possibility that del z upon del x can be calculated, del z upon del y be calculated. Okay, so while calculating the, as we can say, z is dependent on x and y, so while calculating the del z upon del x, remember one thing: in partial derivative we use the keyword that is known as del. Okay, so del z upon del x, let us say if we are differentiating with respect to x, then we'll keep the other as constant. Okay, and let us say if we are representing we are differentiating, partially differentiating with respect to y, then we'll keep the x as constant. Okay, so here can we say the derivative, let me write a statement for you just to revise the things further later on. The derivative of z with respect to x, treating y as constant. So here we are treating y as constant. Okay, and this is called as the partial derivative and is called as partial derivative of z with respect to x. Let us say if here only z is dependent over two variables. Okay, let's write it as case number a. Okay, there might be chances that in some of the cases z is dependent on three functions, let us say x, y and z. So let us say if we are interested in calculating the first order derivative, remember these are first order derivatives, del z upon del x, del z upon del y, these are called as first order partial derivatives. The reason being behind partial derivative, the reason being behind this is called as first order because their power is 1, their power is 1. Okay, now let us say if a function z is dependent upon three variable x, y and z, then if we are interested in calculating the first order derivative, first order derivative, then we can calculate it as del z upon del x, okay, del z upon del y, and del z upon let me write it another variable t, because z can be 2 too, so del z upon del t. Okay, so here you can see z is dependent on x, y, and t. Okay, so how will do the partial differentiation in if it's the case of 3 variable? Then what we'll do, let us say x is the only variable and remaining 2 variables will make them as a constant. So what is the possibility that y and t would be treated as constant? Okay, again in this case here y is there in the differentiation, we are differentiating partially with respect to y, so what are the remaining variables? X and t is remaining as constant. Okay, now in the third case we are partially differentiating with respect to t, hence the remaining 2 variable would be treated as constant. Means the crux is like this: if we are differentiating with respect to a single variable, then make all the remaining other variable as constant. Okay, this is the basic crux of partial derivative. Either it may be case of 2 variables, or either it may be case of more than 2 variables. Okay, now let's focus on some different aspects of partial derivative, because we have covered like single order. So let's say partial derivatives of higher order. Higher order means the power is greater than 1. Okay, so earlier del z upon del x, okay, let's say z is a function of x and y. Okay, then del z upon del x, let's say we are differentiating it one more time, then this is called as del square z upon del x square. So you can see we have differentiated twice and the order is 2. Okay, let us say similarly we first differentiated with respect to y, this is first order derivative. If we'll again differentiate it with respect to y, now this has changed to order number 2. Okay, remember one thing in partial differentiation, okay, we will be like get to know the sum of the terms that we used to represent the first order derivative by pq and second order derivative by r, s, and t. Okay, so let me write the things for you, because that will be required in calculating the maxima and minima for the two variables. So if let's say del z is dependent on del x, two variable x and y, then del z upon del x, then del z upon del y, and then del square z upon, or we have already written here, this is called as p, this is called as q, this is called as r, this is called as t, and let us say del z upon del x was the expression, and we have differentiated with respect to y, this is called as del square z upon del y into del x. And this is the same case with like del z upon, let's say first we differentiated with respect to y, and again we have differentiated it with respect to x. So this value will be same, either you differentiate it first x and then y, or first y then x, the results will be same. So this is nothing but called as s. Okay, so you need to remember this thing: p with respect to x, with respect to y q, double derivative with respect to x is r, double derivative with respect to y is t, and double derivative with respect to two variables, that is first either of the x and second either of the y, and or in first case maybe y or second case maybe x. Okay, let me write some examples to make it more clear, to have a more clarity. Though these examples might not be given in the examination, let us say if a function is given as z is equals to 3x square y plus 3y square x. Okay, so let's first calculate the first order derivative. So first order derivative, so what are the first order possible derivatives? Can we say del z upon del x, because you can see z is a function of two variable x and y, so we can differentiate it with respect to two variables only. So let's first differentiate with respect to x, and we have already said when we'll differentiate with the first variable, we'll keep the next as constant. Okay, so here y would be treated as constant. Clear? So can we say 3 is a constant, y is also constant, only x square is remaining in the first term. So can we say del by del x of x square plus, now let's move on to the next term. 3 is constant, y is constant, and y square would be constant, so constant square is also constant, so 3y square, keep it as constant. Can we say del by del x of x? What's the value of this differentiation of x square? Can we say this is nothing but 2x and this is nothing but x, so your final answer would be 6xy plus 3y square. Okay, now let's calculate the del z upon del y. Remember one thing, that here we are calculating the first order derivative with respect to y. So what's the next variable or other variable? X, and that would be treated as constant. So we'll treat x as constant. So again, from the function, from the equation number 1, let us say 3 is constant and here x is constant, so x square will be constant. What is the remaining term? Del y upon y. Now let's talk about the second term. 3 is constant, x is constant. What is the inside term? Now remaining term is y square. Okay, so what's the differentiation of this is 1. What's the differentiation of 1 is 2y. Can we say the answer is 3x square plus 6xy. Okay, so this is the first order derivative. Okay, let me calculate the second order derivative for you. Okay, second order derivative means that the power is 2. Okay, so second order derivative, by only one numerical you will get all the concepts. If you look at the video very precisely, stop and look at the solution. So earlier del z by del x, what we found, this is nothing but 6xy plus 3y square. Let's say we are differentiating it once more with respect to x. So can we say del by del x, and this is the one. Remember one thing, again we are here differentiating with respect to x, so can we say here y would be treated as constant. If y is constant, then 6 is constant, y is constant. What is the term remaining? X plus 3 is constant, y is constant, 3y square. Can we say del by del x, and inside there is no other term remaining, so can we write it as 1? So here differentiation of this is 1, differentiation of constant is 0, so final answer is 6xy. Okay, and this is nothing but called as del square z by del x square. Clear? Now let's move on to, let's say we have del z upon del x is nothing but given, we have calculated in the left side, that is 6y plus 3y square. Let's say now I am integrating with respect to y. Okay, can we say del square z by del y into del x? Okay, so what we are doing, we are just integrating with respect to y. So again, when we are integrating with respect to y, so what's the other variable? X, and that would be treated as constant. So x will be treated as constant, so keep the x constant. 6 is constant, x is constant. What is the inside and the remaining? That is y plus 3 is constant, y is constant, and there is no term of x, so write it as 1. What's the differentiation of this is 1. What's the differentiation of this is 0. Can we say the final answer is 6x? Clear? Oh, here that's a mistake basically. That would be 6y. Okay, clear. Now let's move on to this part. Let's say del z by del y. Okay, del z upon del y, what is the result we have got? That is 3x square plus 6xy. Okay, now we are again differentiating with respect to y, so del by del y and del by del y. Okay, and this is nothing but written as del square z by del y square. Okay, so here you can see all have here 2 mentioned, 2 mentioned, 2 mentioned, so that is the reason it is called as second order, but here only one, so that is called as the first order derivative. Clear. Now here y is there mentioned at the denominator. We are partially differentiating with respect to y, so what will be constant? Will keep the x as constant. Okay, so keep the x as constant. 3 is constant outside, x is constant, so x square is constant. What's inside? Del y of 1. Again 6 is constant, x is constant, del by del y of 1. Okay, differentiation of 1 is 0, differentiation of 1 is also 0. Okay, so sorry, this is 1 na, del y by del y, this is 1. Okay, so can we say the answer is 6x. Okay, so the basic crux is like this. Here we have made the things easy for you, that if it's a dependency over two variable, while partially integrating with respect to x, will keep y as constant, and when we are partially integrating with respect to y, then we'll keep x as constant. Let me consider a simple example, one more example for you to make the more things clear about the three variable. Let's say z is a function given by x y square, or you can say like, let's assume t is given by x y square z plus z square xy. Okay, so what's the first order possible, first order derivative? That is del t by del x. Can we say here t is a function of three variable x, y and z? So del t upon del x, del t upon y and del t upon del z. There are the first order derivatives possible. Remember, when we'll partially differentiate with respect to x, then we'll make the remaining two variables as constant. So what are the remaining two variables? Y and z is treated as constant. Okay, so let's make them constant. So what's the first term? Y is constant, so y square will be constant, z would be constant. Keep the constant term outside, and this will be del by del x of x plus y is constant, z square is constant. Can we say del by del x of x? Can we say this is 1, this is 1? So what's your answer? Y square z plus yz square. Okay, now let's talk about the second term. Here we are partially differentiating with respect to y, so what's the remaining other term? X and z would be treated as constant. Okay, now again from equation number 1, what are the constant? X is constant, z is constant. What's the remaining term? That is y square. Again x is constant, z is constant, so what's the remaining term? This is y only. What's the differentiation of this? Is 1. What's the differentiation of y square? Is 2y. So what's your final answer? Can we say 2xyz plus xz square? Okay, now let's talk about the third. We are partially differentiating with respect to z, so what are the other variables possible? That would be constant x and y. Okay, now again from the equation number 1, x is constant, y is constant, make them outside. Del z by del z of z, again x is constant, y is constant, del by del z of z square. What's the differentiation of this? 1. What's the differentiation of this? 2z. So what's your final answer? Xy square plus 2xyz. Okay, So these are the simple examples for you so that you can revise the concepts of partial derivative. Okay, now we'll focus on the academic perspective. Okay, this was the basic crux for you to solve the questions. Okay, now let's talk about the some of the questions. Question is like this: find the first and second derivative of z is equals to x cube plus y cube minus 3axy. Okay, 3axy, this is the given. So here you can see z is a function of two variable x and y. They are asking about the first as well as second order derivative. So what are the first possible derivative? Del z upon del x and del z upon del y. Okay, so again same thing, we are differentiating with respect to x, then we'll keep y as constant, and here we are differentiating with respect to x, then we y, then we'll keep x as constant. Okay, now y is constant, so can we say first term there is no y, so can we say directly write del by del x of x cube plus y cube is constant, so can we say del by del x of 1 minus 3 is constant, a is constant, and can we say y is constant, del by del x of x remaining. So what's the answer of this? Can we say this is 3x square, this is 0, this is 1. So what's your final answer? Can we say 3x square minus 3ay? Got it? Now let's talk about the second part. Here we are differentiating with respect to y, so x would be treated as constant, so keep the x as constant, so x cube is constant taken outside, del by del y of 1 plus del by del y of y cube minus 3, a is constant, x is constant, inside is del by del y of y. Can we say this is 1, this is 3y square, and this is 0. So your final answer is 3y square minus 3ax. So these are the first order derivative. Okay, now let's calculate the second order derivative. So second order derivative is like in just previously we have covered, so we'll differentiate it one more time. So del z upon del x, or let me do it here. Okay, so what's the del z upon del x? We got 3x square minus 3ay. You can see this is equation number 2, this is equation number 1, this is equation number 3. Okay, now take the derivative again with respect to x. Okay, so again when we are keeping x as constant, then when differentiating with respect to x, then what would be constant? Y would be constant. Okay, so again 3 is constant, x is x square will be constant, inside del y by del y, in del by y, sorry, 3 into del by del x of x square minus 3 is constant, a is constant, y is constant, so del by del x of 1. Can we say this is 0, this is 2x, so answer is 6x. Copy, and this is also called as del square z upon del x square. So this is second order, you can see the power is 2. Similarly, now from equation number 3, if you see del z upon del y is 3y square minus 3ax. Okay, now what we'll do, we'll partially differentiate with respect to y, so del by del y. So again we are in partially differentiating with respect to y, what will be constant? X will be constant. Okay, so x will be constant, again 3. Okay, and there is no term of x, so del by del y of y square minus 3 is constant, a is constant, x is constant, so del y of 1. This is 0, this is 2y. So what's your answer? 6y, and this is nothing but del square z by del y square. Okay, now what's the remaining term? What's the next term remaining? Again, from equation number 3, del z upon del x is given as 3x square minus 3ay. Okay, remember one thing, in the first case here we took this case and we did with respect to x. Now we'll differentiate with respect to y. So what would be this? Del square z by del y del x. Okay, so let me do it for you. So here del by del y, so what would be constant? X would be treated as constant. So x is constant, 3 is constant, x is constant, so x square will be constant, del by del y with 1 minus 3 is constant, a is constant, del by del y of y. Can we say this is 0, this is 1, so answer is minus 3a. Okay, so this equation number 2 and 3 are the first order and these are the second order. Okay, and one more thing I wanted to prove to you, that we already covered that del square z by del y by del x or del square z by del x del y both are equal in nature. Okay, how? Let's prove it here. So let's say first we are taking now from equation number 3. Let's say del z by del y, what we have calculated, that is 3y square minus 3ax. Okay, now differentiate it with respect to x. So del by del x and del by del x. So again we are partially differentiating with respect to x, then what will be made constant? Y would be made constant, and this is nothing but del square z by first del x and del y. So we are integrating with respect to x, y is constant, so 3 is constant, y is constant. Can we say del by del x of 1 minus 3a and del by del x of x? Can we say this is 1? Again you can see both the results are minus 3 and minus 3a, hence it doesn't matter either you do first x or y or first y or x, it doesn't matter, the results will be same. Okay, now let's take one more question for you. Let's say a question is there, that is u is equals to sine inverse of x by y plus tan inverse of x by y. Find the value of x del u by del x plus y del u by del y. Just pause for a minute and just look at the think of the solution. So again, if you look at the question here, can we say u is a function of x and y? And remember one thing, here sine inverse term is mentioned and tan inverse term is mentioned. Okay, so before diving into this question, you must be aware about the differentiation of sine inverse x. So let me write it here, that's differentiation of sine inverse x is given as 1 divided by under root of 1 minus x square x. Okay, and differentiation of tan inverse x is given as 1 divided by 1 plus x square. Okay, so here first del u by del x we required. So del u by del x means y would be treated as constant. Okay, and try to practice in such a manner, because it's a new topic for you, and writing all the things as y is constant, this will boost your confidence while solving the problems. Okay, so what's the differentiation of sine inverse x? That is 1 by 1 minus x square. So let me do it for you. 1 divided by 1 minus x by y ka whole square under root. Okay, now we have, now we just took this as x, then we'll further differentiate it as x na? Then del by del x of x by y. Okay, similarly tan inverse x. So what's the differentiation of tan inverse x? 1 by 1 plus x square. So 1 by x square plus y square, and further del by del x of x by y. Okay, now here again it's with respect to x, then what will be treated as constant? Y would be treated as constant, and here y would be treated as constant. Okay, so let me simplify the terms for you. Can we write this as 1 minus x square by y square, and here y is constant, then we can take out 1 by y, and inside it can be like del x by del x, and here 1 by 1 plus x square plus y square into y is constant, can we say take the term, and del by del x of x. Okay, so okay, sorry, this is my mistake. Here the question is a bit different. Y by x. Okay, so let me correct the things for you. Can we say this is 1 this is 1 plus y square by x square, and del by del x of y by x. Okay, so y 1 by x square plus y square, and x square will be at the top. Okay, we just reformatted this. Okay, so again here we are partially differentiating with respect to x, then y would be treated as constant. So keep the y as constant. So can we say y would be outside, and that is del by del x of 1 by x. Okay, now reformat this as also. Can we say this is nothing but y square minus x square under root, and y will be at the top, and 1 upon y, and differentiation this is 1, plus x square by x square plus y square, can be say y, and what is the differentiation of this 1 by x? differentiation क्या होगा? 1 minus 1 upon x square. So minus 1 upon x square cancel out, y cancel out. What is the answer? 1 by under root of y square minus x square minus y divided by x square plus y square. So we were able to first calculate the del u by del x. Okay, let me keep the things on a single page for you. Okay, now let's talk about the next part, that is del u upon del y. So again del u upon del y. So del u upon del y means x would be treated as constant. Okay, so x is constant. Can we say again differentiation of sine inverse x is 1 by 1 must to replace again 1 by 1 minus x by y ka whole square under root, and further differentiate with respect to y, that is x upon y, and again 1 divided by 1 plus y by x ka whole square, and d by del y of y by x. So here we are partially differentiating with respect to y, then x will be treated as constant, and here y then x is constant. Okay, so can we say 1 by under root of 1 minus x square by y square, and x is constant, keep the x as outside, del by del y of 1 upon y, and this is 1 by 1 plus y square by x square into x is constant, so 1 upon x is constant, and del by del y of y. Okay, can we rephrase the first term, that is y divided by under root of y square minus x square into x. What's the differentiation of this? Minus 1 upon y square. Okay, so can we say x is constant, 1 upon y minus 1 upon y. Okay, can we say minus y square, and 1 y will be cancelled, so can we say x divided by y into y square minus x square. Okay, clear hai? Now let's talk about the second part. Can we say x square divided by x square plus y square? X is constant, so 1 by x would be constant, and this will be 1. So can we say the answer is x divided by x square plus y square. Okay, we are doing something wrong, I guess. Del u by del y, let me check this. Del 1 minus x square by y square minus x by y square. Okay, let's just check it. So this is your a, this is your b, and what in the question it is asked? X into del u by del x plus y into del u by del y. So x, what is del u by del x? Write it here, 1 by under root of y square minus x square minus y by x square plus y square. Okay, plus y into x divided by y into 1 y square minus x square plus x by x square plus y square. Just open this. Can we say x by under root of y square minus x square minus xy by x square plus y square plus xy by y into under root of y square minus x square and plus x. Okay, here minus will be there, no? We did a bit mistake here, minus sign will be there, so things will be different for you. Minus and plus x y divided by x square plus y square, so this will be getting cancelled to this, and 1 y will be cancelled to this, so x will be getting this, hence the answer is 0. Okay, so this is all about the first order partial derivative. Okay, let me do a simple example, one more last example, and in the next lecture also we'll try to revise one more question of partial derivative, because total differential is other topic which is going to be covered in the next session. So u is given as e to the power xyz. Okay, find the value of del cube u upon del x, del y and del z. Remember one thing, here u is a function of 3 variable x, y and z. Okay, so let me start from first. We'll differentiate with respect to z, then y, then x. Okay, so what is u? U is e to the power xyz. So first del u upon del z, again when we will be differentiating with respect to z, then x and y would be treated as constant. Okay, so what's the differentiation of e to the power x? E to the power ex itself. So e to the power, here x and y is treated as constant, it does not matter. Okay, so e to the power z ka differentiation e to the power z. Now this will be further differentiated na, x y z. Okay, so z is there, so what would be constant? X and y will be constant. Okay, is constant. So e to the power x y z, take x y outside, and what is the inside? Del over z by del z, this is 1. So what's your final answer? E to the power x y z into x y. Okay, now our first part is solved. Now del u upon del z, what we'll do, we'll differentiate with respect to y. Again, see the problem of the question of term, the z term is now solved, so nothing to worry. Only what will be constant? X would be constant. So what we are doing, del by del y of e to the power x y z into x y. Okay, or x and z will be constant, you can say like this. Okay, so we are differentiating with respect to y, so y term is mentioned over here also and here also. Okay, so we'll apply the product rule. So first keep this as constant and del by del y of xy, and keep the second term as constant and del by del y of e to the power xyz. What we did, we just applied the product rule, that is d by dx of a into b is given as a dp by dx plus b dA upon dx. Okay, so first we took this as constant and differentiated partially with respect to y. Okay, and secondly we kept this as constant and partially differentiated this way. Okay, so you can write the result as e to the power xyz. I am now directly writing the result because you have practiced a lot. Okay, so can we say directly, here y is there, so x will be constant, so del y by del y is 1 plus xy e to the power xy into z, e to the power x and z as constant, so del y by del y xz. So what's your final answer? E to the power xyz, can we say x plus x square yz. Okay, now again the third term, that is del u by del z we have calculated, del square upon del yz we have calculated. Now differentiate again with respect to x, and this is what required in the exam, required in the question. Okay, so del by del x, that is e to the power xyz into x plus x square yz. Again there are two functions, so we'll again apply the product rule. What's the possibility? That is keep the first as constant and take the x plus x square yz, plus keep the second as constant and partially differentiate the first one. Okay, so e to the power xyz, and this would be 1 plus 2xyz. Okay, and plus x square yz, and this is e to the power xyz, and this is y into z. Okay, so if you'll solve these things, you will get the final answer as xyz 1 plus 3 xyz plus x square plus y square plus z square. Okay, so this is all about the partial derivative, though you can practice more examples from either of the book of B.S. Grewal or N.P. Pali. Okay, and just to recall the things once more again, to in the case of partial derivative, let us say if z is a function of x, y, z, two or more variable, then we'll differentiate with respect to x keeping yz constant. we differentiate with respect to y, x and z would be constant. If we are differentiating with respect to z, then x and y would be treated as constant. Okay, remember these things. Okay, thank you.